Hello, Assalamu alaikum.
Assalamu alaikum, sir.
Ji, Assalamu alaikum. How is everyone? How many people are here? Let me.
I think, sir, 6 participants are here.
Okay, all right, all right. Uh, let's wait for maybe just one more minute. I, and then we can just start. I
Okay, sir.
just hope that everybody is okay, safe and sound. सबसे पहले तो आजकल ये पूछना पड़ता है ना कि you're okay, your family members are also safe. Okay,
Yeah, sir.
so
Thank you,
wish
sir.
all of you uh, uh, safe and secure times nowadays. Okay, today's agenda, let me just share what we are going to discuss today. The first thing that we will do today would be to discuss the main method of estimation that we call the OLS method. Okay, so I think I should uh, share my screen so that everybody can see what I have. Is it visible now?
Yeah, sir. It is visible.
Okay, so we would start from the method of OLS, although the purpose is not to go for extensive mathematical derivation involved in this method, but at least we should have the basic idea what this method is all about and uh, how we get the estimators of our regression coefficients through this method. Okay, so let me, anybody can just uh, give me a go ahead if there are sufficient number of uh, students, then we can just start. Okay, so Yasin is here, Shah Hassan, Faiza and Madiha. Who is by the name of Del? Who is this person?
अस्सलाम वालेकुम सर।
Walaikum Assalam.
सर ये डेल जो है ये मैं ही कनेक्टेड हूँ एक्चुअली। थोड़ा मैंने लैपटॉप और फोन दोनों के थ्रू कनेक्ट किया हुआ है
Okay,
ड्यू टू सम। जी सर,
okay,
सर वो साउंड का इशू है तो इस
okay,
वजह से मुझे लैपटॉप और मोबाइल दोनों के थ्रू कनेक्ट करना पड़ा है।
okay, no problem, no problem. Anyhow, welcome to this
थैंक यू सर,
lecture.
थैंक यू सर।
Okay, six. So I think. What do you suggest? Should we start, Madiha?
Sir, I have
यस
text.
जी
श्योर।
जी 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 जी
So
yes
I have text in the official group, WhatsApp groups. So
and what's
most
their
students will
response?
join. Sir, they
Okay,
are joining, sir.
okay, all
I
right,
asked Hakim. They are joining, sir.
okay, okay, good. Okay, so I would start just now. As I had indicated in the last lecture that the method of estimation that we usually use in econometric models or in that matter regression models. I think I have already clarified, but let me just repeat if somebody has not heard that thing. The econometric models that we are actually talking about in this course, they are basically regression models, right? Every econometric model is basically a regression model. That's why we are talking about regression all the time. Although, in strict sense, econometric model involves economic variables. If you just want to keep yourself in a very strict literal meaning. While when we use the word regression model is a general terminology in which the variables involved on the left or as well as the right hand side can be economic variables. They can also belong to other fields of knowledge. So when we use the word regression model, we are not restricting it to a particular type of variables in a given field, as long as we can justify cause and effect type relationship or cause and effect type studies in any field, we can actually use regression models over there. Because I hope now it's quite clear to all of you. Regression analysis basically deals with the study of dependence of one variable on one or more other variables. So there is no particular restriction what should be the nature of the variables. But when we particularly use the word econometric model, in strict sense, uh, we are actually talking about uh, economic phenomena, economic variables, right? But in our course, we will be using the word regression models and econometric models interchangeably. So the thing that I'm trying to tell you right now is that every econometric model is basically a regression model. But every regression model may or may not be, in a strict sense, an econometric model, right? Although people are using the word econometric model uh, when they are actually having some investigation in other fields, like for example, when they will be political scientists, when they are using these models over there, they are still saying that we are using econometric models, right? So basically, if econometric models are used in other fields of knowledge other than economics and its related fields, uh, if you use the word econometric model, there is nothing wrong, but basically they would be regression models. So therefore, I just wanted to clarify this confusion, why sometimes you will just hear from me the word regression model, and sometimes I'll be saying econometric model. In this course, they are one and the same thing, but in any other setup, they may not exactly be the same. But for us, they are just interchangeable. So the most commonly used method of estimation in econometric models or regression models is the ordinary least squares method. If you recall from our previous discussion, let me just show you something over there. In the last lecture, we were actually talking about uh, sample regression function, and there we said that what we call sample regression function is basically the sample counterpart of the population regression function. Okay, so if you recall, the population regression function was something like this. Okay, this one. Yeah, expected value of y given xi, the conditional mean, equal to function of x. And in our example, this conditional, the f of x is written as beta 1 plus beta 2x, which means a straight line. And I hope now it's quite clear why we are saying it should be a straight line, because the graph is clearly a straight line, although we may not always be fortunate to assume or to know that it is really a straight line. But even then, if we have no other knowledge, we would start by assuming that it is a straight line. Uh, Although there may be other options available for that. So for this particular PRF, which is a function that we use or we consider in case of population data, if population data are not available, which means if we are not studying the population, rather we are considering a sample from the corresponding population, then we need a sample version of this function. So this is called PRF, and what we call SRF, like this, okay, this one. What we call the SRF is basically the sample counterpart of that thing that we call the PRF. In practical terminology, it is actually the SRF that we call our estimated econometric model or estimated regression model. So therefore, in our next discussions from this lecture onward, whenever I am talking about estimated regression model or estimated econometric model, actually I'll be talking about the corresponding SRF, right? So I may not always be using the word SRF, but from this lecture onward, it should be very clear to all of you that the SRF, the estimated regression model that we use in real life is basically the SRF that we are talking about. So in the given case, because we are talking about a single X variable, so the SRF would be given by Y hat. The subscript is just representing the ith unit. So yi hat equal to beta 1 hat plus beta 2 hat xi, okay? And then in the last lecture, I don't know whether we had gone for a clear discussion of this or not, but anyhow, I will quickly just repeat. In this expression, y hat represents the estimator of the left-hand side of PRF. What was there in the PRF? The conditional mean, right? So the y hat is actually representing the conditional mean. It is an estimator of expected value of y given x. When in statistical notation, whenever we put a hat or a notation, this actually means that we are talking about the estimated quantity from the sample data, right? So the sample quantity would be represented by putting a cap or a hat, H-A-T hat over there. So when we use the word beta 1 hat, and when we use the notation beta 2 hat, actually we are talking about the sample versions of beta 1 and beta 2. So therefore, what is beta 1 hat? It is an estimator of beta 1. What is beta 2 hat? It is an estimator of beta 2. Remember, whenever we use the word estimator, actually we are talking about a sample function that is used to estimate the corresponding parameter. So the parameter is beta 1, and the estimator of beta 1 is beta 1 hat. At this point, I also find it necessary to mention that in statistical terminology, we use two words. One is the word like this, which you see on the screen right now, estimator, OR at the end. And the other word is estimate, E-S-T-I-M-A-T-E. Okay, so although it's very simple, but just for the sake of continuity, I would just repeat that sometimes we use the word estimator and sometimes we use the word estimate. So what's the difference between the two? Estimator, the word that you see on the screen right now, refers to the function, and usually we say the function of sample values. Estimator is the function, or in easy words, you can say the formula that you use to estimate a parameter. While estimate, when TE at the end, the estimate would be a particular numeric value of that estimator using a given sample data. So for example, as you will see in few seconds, beta 1 hat would be basically a function. It would be a formula. And you will be using that formula to estimate the value of beta 1. So beta 1 hat in mathematical form would be actually an estimator. And once you use a particular sample data on X and Y and put the corresponding results into the expression of beta 1 hat, the particular numeric value that you will get as a result of that calculation would then be called the estimate. So estimate is a particular numeric value of the estimator, okay? Another thing that I would like to make clear here, that because the value of estimator, the numeric value that you can calculate for an estimator, it depends on a particular sample. For example, sample number 1, right? Like, for example, if you consider this one, suppose the table 2.4 that we discussed in the last lecture, this can be considered as one sample. And for example, table 2.5 can be considered as another sample of size 10. And similarly, you can consider a number of different possible samples of size 10 that can be taken from that particular population of table 2.1. So if we use the formula for beta 1 hat using this data, table 2.4, then you would get one numeric value of beta 1 hat. But if you change your sample to this one, table 2.5, it's very clear that because you are changing the data, so the numeric value of beta 1 hat would also change. And similarly, if you consider another sample, a third sample, fourth, fifth, sixth, seventh, eight different samples, the numeric value of beta 1 hat would change. So we say that beta 1 hat, okay, beta 1 hat is basically a random variable. I'm using this particular terminology, I'm repeating. Beta 1 hat, or in other words, estimator, is always a random variable because its value changes from one random sample to another random sample. You change your sample and the numeric value of the estimator would change. So therefore, it would not remain the same for all samples. In contrast to that, the beta 1, which is the parameter, right, would be a fixed number. It would be a constant. So although beta 1 would be unknown when we don't have the population, but it should be very clear that beta 1 is a single number in which we are interested, while beta 1 hat is actually not a single number. For a given sample, of course, it would be a single number, but if you change your sample, its value would change. So beta 1 hat, in statistical terminology, we also call it a statistic, right? Without S at the end, statistic. Statistic and estimator are actually one and the same thing. What is a statistic? It is actually, again, a function of sample values. At elementary statistics courses, I hope you have already learned that for there is something that we call parameter, and there is another thing that we call statistic. Gee, just to refresh the memories, can I ask, for example, what is the difference between statistic and parameter? G. Anyone? Hello?
हेलो सर।
जी आवाज आ रही है आपको?
जी सर, स्टैटिस्टिक और पैरामीटर
जी जी
लाइक दिस सिमिलर टर्मिनोलॉजीज, बट जो डिफरेंस है सर स्टैटिस्टिक और पैरामीटर्स का, वो ये है कि स्टैटिस्टिक बेसिकली डील कर रही होती है सैंपल के साथ, और पैरामीटर जो है सर वो इंटायर पॉपुलेशन सर के साथ डील करती
And what actually they represent? For example, can you remember any example?
है।
We said this is parameter. So basically, parameter क्या represent करता है? And when we say this is a statistic, so what does that represent? Uh, Initially, it would seem quite strange why I'm asking this thing, but conceptually, it's very important because the word
जी सर।
parameter and statistic, these would be part of our discussion till the end. So I just consider it necessary that if there is any confusion regarding the terminology of parameter and statistic, so it should be very clear right from here. You see on this slide over here, note that an estimator, also known as a sample statistic, right, is simply a rule or formula or method that tells how to estimate the population parameter from the information provided by the sample at hand. So that's why I'm saying that because the word statistic and parameter are occurring as part of our discussion. So it should be very clear, or at least I should be very clear that you know uh, what these things actually represent. G. Anyone, for the sake of discussion? Or should I tell right now
Mm,
without wasting the time? Okay, let me quickly tell you so that it becomes quite clear as we move forward. By definition, parameter refers to a numeric characteristic of the population. Okay, parameter refers to a numeric characteristic of the population. And statistic without s at the end, right? Statistic, whose plural is actually statistics. Statistic is the sample counterpart of parameter, which means you can say if parameter represent the numeric characteristic of the population, then a statistic represent the same numeric characteristic of the sample. Okay, so as an example, just a very simple elementary example, you are all familiar with the phenomena of mean, and you know that mean can be calculated for all the whole population, and you use the word population mean for that purpose. But when you calculate the mean for the sample data, then you use the word sample mean, right? ये तो clear है ना? Okay.
जी सर
So
जी
population mean is actually a parameter, and sample mean is basically a statistic. Okay, why? Because population mean, when you calculate the population mean, the mean for the whole population, then it represents a particular numeric feature of the population, because it represents the central value or the center of the data, right, or typical value of your distribution. And the sample mean representing the population mean gives you the same information regarding your sample. So therefore, when you want to study population, you will study the population through one or more parameters. Just like, for example, if you want to describe a person, अगर मैं ये कहना चाहता हूँ कि for example I am talking about a particular person in my class, so sometimes in order to describe that person, I will describe the person by using certain features, some features which are common to human beings, like physical features or other intellectual features and so on and so forth. Okay, and those description of those features would help to characterize the uh, the persona of that person. So same is the case with data. When you want to describe a phenomena, and on that phenomena you have generated data, so you calculate some particular numbers from that data, and the purpose of those numbers is to describe that particular set, whether it's a population or whether there's a sample. So those numbers which we use to characterize the set, by set I mean it can be the whole set like population, or it can be a subset like a sample. So those characteristics, those numeric characteristics, are then given the names of parameters in case of population data, and they are given the name of statistic in case of sample data. Because population can be described by more than one parameter, so that's why there can be a number of parameters to describe a population, and consequently there can be as many statistics to describe the corresponding or to estimate the corresponding parameters. So therefore, keep in mind that in case of a regression model, beta 1 and beta 2, beta 1 and beta 2, which are appearing in population regression function. Uh, this meeting will end in 10 minutes. Uh, okay. Would it work right now? If I click upgrade, I hope this will not create any problem. Is it okay? All right. Uh, so therefore, in the context of econometric models, these betas, beta 1 and beta 2 in the given case, they will be considered as parameters. Okay, because they represent the features for the whole population. And beta 1 hat and beta 2 hat, they will be the corresponding statistics, right? So beta 1 hat is a statistic for the parameter beta 1, and beta 2 hat is a statistic for the parameter beta 2, right? So estimator and statistic, they are used interchangeably. Every statistic is basically an estimator. Why? Because every statistic would always be used to estimate the corresponding population parameter. Like you know that sample mean is used to estimate the population mean. So therefore, beta 1 hat would be used to estimate beta 1 and beta 2 hat would be used to estimate beta 2. So therefore, we would be using estimator and statistic interchangeably. But keep in mind, as I have already told you, that every estimator, and in that sense, every statistic is basically a random variable. Why it's a random variable? Because it would take different values for different samples. While parameter would always be a fixed number, okay? But as long as you're not studying the population, the parameter would remain unknown, and your job is to use a proper estimator for that parameter. So now we have introduced these notations in the form of SRF, and we say beta 1 hat is an estimator of beta 1, beta 2 hat is an estimator of beta 2, okay? And the next natural question would be, how can we uh, get the functional form of beta 1 hat and beta 2 hat? This is called estimation of beta 1 hat and beta 1 and beta 2. So for that purpose, what we do, we actually use the method that I'm talking about right now. Okay, the method of ordinary least square. G. Okay, so the OLS method, which sometimes is also called the least square method, okay, is the most popular method in econometric, in the estimation of econometric models. Uh, why we just call it the OLS method? Because the method which is used in its very basic form or initial form is actually given the name of OLS method, ordinary least square method. Because there are also other slight variations of the least square method that we will be considering in this course. Uh, just to name some of them, like we will be talking about the GLS method, generalized least squares method. We will also be talking about the weighted least square method, WLS method. We will be also talking about, although we may not be using it, but for example, there are other versions of this, indirect least square method, which we call the ILS method, two-stage least square method that we call 2SLS method. So because this OLS is the most fundamental form, the basic form of that method, so that's why we call it the OLS method. So OLS method is based on a principle that we call the least square principle, and least square principle says that the sum of squares of the residues should be minimized if you want to get beta 1 hat and beta 2 hat. But before we can just discuss that one, okay, uh, what is a residue? Residue is basically defined as this difference, yi minus y hat, okay? Residue is denoted by ui hat, and it is defined as y minus y hat, okay? What is y? Remember, one thing that I should tell you, residue is the sample version of the disturbance term, the error term, okay? If you recall, uh, this is actually the population form of the simple regression model. Simple regression in the sense that we have only one explanatory variable. The UI occurring over here is called the error term or the disturbance term. But this is actually the expression in case of the whole population. For the sample data, the same expression can be written as yi equal to beta 1 hat plus beta 2 hat xi plus ui hat. Now in this expression, everything represent uh, the sample data, like yi over there represent the ith value of dependent variable in the population, but in the second expression yi represent the ith value of the dependent variable in my sample. Beta 1 is the intercept for the whole population. Beta 1 hat is the estimate of beta 1 using the sample data. Beta 2 hat is the estimate of the slope beta 2 using the sample data. Xi is the ith value of the independent variable in my sample. And ui hat, when I put a hat, actually I'm talking about something which is estimating ui. So ui is the disturbance term and ui hat is the sample version of the disturbance term, right? And we say that whatever role is served by the disturbance term in the population, the same role is played by the residual, right? The residual in case of sample. So therefore, if this part beta 1 plus beta 2 xi represent the conditional mean, then this part beta 1 hat plus beta 2 hat xi represent what? The yi hat, okay, the SRF. So therefore, in sample form, we can just write down yi equal to yi hat plus ui hat. And from this expression, we can say that ui hat, the residual, can be written as the difference between yi and yi hat. Okay, yi and yi hat. Let me check whether there will be any problem because we have 2 minutes and 19 seconds left. So is there going to be any problem with respect to our connectivity? Or would it be automatically continued?
नो सर, ये आफ्टर 2 minutes ही वाइंड अप हो जाएगी सेशन सर.
So can you log in again? Is it
Yes sir,
possible?
we have to log in with the same ID and password.
Okay, okay.
But
So
सर अगर आप अपग्रेड कर दे सर तो ये कंटिन्यू हो जाएगा सर.
तो upgrade तो मैंने I don't know whether I'm allowed to upgrade it because this would be done by the I think this would be done by the administration in Cordoba. ठीक है ना?
या सर.
But anyhow,
सर खैर है सर, we हम सेम आईडी और पासवर्ड के साथ दोबारा लॉग इन.
So it should be clear to all of you that once the session ends, we have to immediately log in again, ठीक है? So that we can continue from there. Okay. So within this 1 minute, we have to just cover some basic ideas before we actually discuss how this method is actually applied. Okay, let me quickly just go over there. So therefore, the first thing that you should learn in OLS method is the idea of residue. So what is residue? It is the difference between the observed value of y in the sample, which is yi, and the estimated average value of y, which is coming from the fitted model. Okay, so y minus y hat is the definition of residue. And then if you replace y hat by its expression, it would become yi minus beta 1 hat plus beta 2 hat xi. Okay, so therefore this would be thing. Okay, so I would just log out and we will log in again so that we have no problem. So just for 1 or 2 minutes, we'll be just going out, okay, and then coming back. Okay.